Hi everyone, this is Mr. Youngren again, and I'm going to lead you through section 5.3, where we're going to use kind of same ideas as what we talked about in 5.2, but just with different formulas. So there's a few more that we're going to add to the collection we've already got going on. And let's go ahead and just jump right into it. So the first thing is just listing out what's called the double angle formulas. And basically what this is saying is sine of 2 times an angle, thus double the angle, gives us really, we have three different types of double angle formulas, depending on what we're doubling, whether it's sine, cosine, or tangent. Now, like I mentioned yesterday with those formulas, I'm not expecting you to memorize these. I will provide them for you, but we need to know kind of how to use them and how to come up with values with these double angle formulas. So let's go ahead and just put this to use. So example one reads, if sine of theta equals 5 over 13 and theta lies in quadrant 2, find the exact value of the following. So we have to set up what this is describing, the sine of theta equals 5 over 13 and the angle being in quadrant 2 first. This allows us to find values of cosine and then tangent. So what I did is I said, okay, let's make this angle where I'm going to draw this line in quadrant 2. So that's giving us that angle of theta. And one thing we know about this line is that sine of this angle is 5 over 13. And in general, sine of any angle is equal to the y-coordinate over the radius, or r. So we know that the length here of this line is 13. The y-coordinate is 5. And then in order to find x, which I've already done, but to find that, I had to use my Pythagorean theorem. So if I drew a line down here, right, we know that y is 5. We don't know x. So x squared plus 5 squared equals that radius squared, 13 squared. So after a little simplifying, we get x squared is 144, giving us that x is 12. Now the fact that we're in quadrant 2 means that x is negative. So this is a negative 12. And so now we're able to use this diagram to find values of sine, cosine, and tangent, and thus sine of 2 times that angle, cosine of 2 times that angle. So the first thing is, let's go ahead and bring in our double angle formula for sine. So instead of sine of 2 times that angle, we need to do 2 sine of theta, cosine of theta. Some of these things we know, right? Sine of theta was given to us in the beginning of the problem. That was 5 over 13. Cosine of theta, we need to use this diagram. Cosine is the x, so negative 12, over the y, which is 13. And so we just need to multiply all three of these things. I'm going to multiply the fractions first. So 5 times negative 12 is negative 60. And then 13 times 13 is 169. And then 2 times this fraction, really we're just doing 2 over 1 times negative 60 over 169 is negative 120 over 169. And you can see it's kind of tempting to just say, couldn't we just double both sides here and that equals sine of 2 theta? Well, no, because we're not doubling the value of the angle or the value of sine. Rather, we're doubling the angle. So instead of 2 times 5 over 13, we had to do 2 times theta, which is giving us a completely different value than just simply doubling the value of that sine of theta. So we need these formulas. This helps us find the values pretty quickly. All right, so just moving along, let's go ahead and find cosine of this double angle. So again, using our cosine formula here, we need to cosine squared of theta minus sine squared of theta, where cosine of theta will square that value. So cosine of theta we found to be negative 12 over 13, and that value needs to be squared, minus sine of theta, which we know we were given it at the beginning, is 5 over 13, also needs to be squared. When I'm squaring this, remember what it means to square something, right? It's this number times itself. So really I'm squaring the top and the bottom because it's negative 12 times negative 12 and 13 times 13. So this gives me 144 over 169 minus 25 over 169. Luckily, we have a common denominator, so the subtraction is pretty easy, giving us 119 over 169 for the value of cosine 2 times the angle theta. All right, and last one is tangent 2 times the theta. So we need to do 2 times tangent of that angle. and then 1 minus tangent squared of that angle. Well, tangent is equal to y over x. So I first need to do 2 times 5 over negative 12. On bottom, keep that 1 there for now. And then we need to do 1 minus tangent squared, so 5 over negative 12 squared. And this has created a little bit of a mess. So let's start with, what can we simplify? Well, up top, I can do 2 times 5 twelfths, give me 10 over negative 12. On bottom, I can go ahead and square 5 over negative 12, giving me 1 minus 25 over 144. Now, really, we want just one simple fraction in our denominator. Then we can go ahead and easily take the top divided by the bottom. Before that, it'd be really tricky with this 1 being right there. So I'm going to get a common denominator. I know that 1 is equal to 144 over 144. And we're going to take away 25 of those 144ths. So that gets us to 119 over 144. So let's just continue the work up here, where I still have 10 over negative 12 divided by 119 over 144. And the last thing we need to do is the copy dot flip, or divide into 2 fractions. So 10 over negative 12 times 144 over 119. These values are large, so I'm going to use a calculator. And likely I'm going to have to reduce down this fraction. Remember, when you're working on Math Excel, they're going to always want your answers reduced. And with a calculator, we can reduce numbers pretty easily. So negative 1428. So that's a big fraction. So in my calculator, I'm going to go 1440 divided by negative 1428. Gives me some decimal. In order to convert that decimal, I'm going to hit this math button underneath alpha, brings up a whole list. The first option is just frac, meaning take that decimal and convert it to a fraction. And it reduced it down for us, giving us negative 120 over 119. And that's the answer that Math Excel likely wants, unless it wants it in a decimal form. Most calculators will have some way of converting a decimal to a fraction. So if you're using a calculator different than mine, there should be a way to do that. Okay, well, let's go ahead and, just like if you watched the previous video, I'm going to ask that you pause the video and practice what I just showed you. So here's checkpoint 1. Again, do your best. I'll have the answers. I'm going to keep that discussion pretty brief just to kind of limit the length of this video. But for now, go ahead and hit pause, and then I'll have the answers for checkpoint 1 here in just a moment. All right, well, here are your values. Basically works out the exact same. Just make sure you're checking the simplifying as you get your answers down to that final fraction, which again needs to be in reduced form, especially when you're typing it into Math Excel. One that gets a little tricky is tangent, because we do have the top fraction and then the bottom fraction that needs to get simplified into one single fraction. So know that I did not show going from 1 minus 16/9. I didn't show the common denominator. Remember, 1 is just 16/16. Or sorry, we don't want 16ths, we want 9ths. Let's try that again, 9/9. So the 9 minus 16 is how I'm getting this negative 7 up here. Right, that's the one thing that, or the one step that I'm not necessarily showing there. So as you check your work, feel free to pause it just to give you plenty of time to make sure all your steps are similar to mine, or yeah, should be identical. And if you're just writing these down, then take your time to write them down. All right, well, let's keep on going. And the next thing that we're going to do is really just work in reverse. These go a little bit quicker. And it's just recognition, right? So I'm recognizing here, this looks a lot like that double angle for tangent. Well, what that formula tells us is that if we have tangent of 2 times some angle, that equals 2 times the tangent of that angle divided by 1 minus tangent squared of that angle. So how I know that I'm going in reverse here is I'm like, okay, since I recognize that this double angle form for tangent is exactly what I'm seeing here, the only thing different is that we know the value of theta, right? Theta is 15 degrees. So really we're finding tangent of 2 times theta, or tangent of 2 times 15, which is pretty easy, right? 2 times 15 is 30. So I need to find tangent of 30 degrees. Well, like we've been doing quite a bit now, let's think about what is the value of tangent of 30 degrees. And you need to think about your unit circle here. Well, at 30 degrees, that's that first kind of line on that unit circle where we know that I'm going the furthest over. So I want my largest value that we see on the unit circle, which is √3/2, and the shortest distance up. And that shortest value or smallest value is 1/2. So then tangent of any angle, or tangent of 30, is equal to y/x. So 1/2 over √3/2, where I need to go ahead and simplify the fraction by copying the top and multiplying by the reciprocal of the denominator. So the 2's cancel, giving me 1 over √3. But remember, we don't want square roots in our denominator, so I need to multiply by √3 over √3, giving me √3. The square roots cancel out the squaring, so it's just 3. And thus, this is equal to √3 over 3. So we found the value of tangent of 30 degrees, which is equal to 2 times tangent of 15 divided by 1 minus tangent squared of 15 degrees. And that's it. All right, so see if you can work backwards. This time we're given a different double angle formula, so you might need to refer to those double angle formulas in order to go in the reverse order. So what is this one referring to? All right, so once again, go ahead and hit pause, work through this. I'll have the solution for you after you unpause. All right, a little bit easier, at least I feel like it is, because, well, first off, I recognize that cosine squared minus sine squared of any angle is the double angle formula for cosine of 2 times that angle. So theta in this case is 15 degrees, so really we're working on finding cosine of 2 times 15 or cosine of 30. Well, at least I have my values at 30 degrees on the unit circle already up here. And cosine of any angle on the unit circle is just the x coordinate, which is √3/2. So that's all the work that needs to get done there. So cosine squared of 15 minus sine squared of 15 equals √3/2. All right, let's keep moving along here. And like I said, just kind of throwing a bunch more formulas at you. Don't worry about memorizing these. We'll always provide them. And this actually tends to get a little tricky because it's like, when do we know? So there's a bunch of different forms of the cosine double angle formula. In fact, there's 3 different. So when we're using these, especially to verify identities, it can be tricky sometimes to figure out which one do we want to use here. And a lot of times, there's not a clear path. There's not an obvious choice. So we might need to do a little bit of trying, maybe not get anywhere, and then try a different form here. So let's go ahead and put this to use, and you can kind of see what I'm talking about. So we need to verify the identity of cosine 3 of theta equals 4 cosine cubed of theta minus 3 cosine of theta. So remember, when we're verifying, I'm just working with one side. And it really doesn't matter which side. We tend to choose the one that is more complicated, but that's not always the case. And honestly, it doesn't matter. We can get there multiple different ways. And in fact, the way that I show you now might be something different than what you thought initially. So we're going to actually work with the left side here. So the left side being cosine of 3 theta. And when we're working on these, the trick is just like an entry point. And I'm like, you know what? I don't have any value for cosine of 3 of theta. I know that from what I learned yesterday, we do have those sum and difference formulas. I also have this double angle formula. So I'm wondering, can I split up 3 theta? And the answer is yes, right? I can split that up into 2 of theta plus 1 more of theta. Well, this allows me to bring in the formula that we used yesterday, or in 5.2, to using that sum formula for cosine, which tells us that we take cosine of the first value, so 2 of theta, times cosine of the second value, which is just theta, and we're going to add that, or excuse me, subtract it to sine of both those angles as well. So 2 theta and sine of theta. So now this has put me in a place where I can use some of these double angle formulas for cosine, and then we have one for sine, that double angle formula, to start to kind of get us in this direction. So, right, it's tricky. Like, how did I know to go from here to there to kind of split all this up? And the answer is, I'm just kind of guessing. I'm like, what can I do with these things? How can I manipulate the equation to kind of get me moving forward in a place where I might be able to match up with the right side. And even right now, I'm not seeing a clear path, but I'm just trying things and seeing where it takes me. So I'm like, okay, cosine of 2 theta. We have a bunch of different forms up here. And the one that we're actually going to pull in is this 2 cosine squared theta minus 1. Now, the reason that I'm thinking that is I notice I have this cosine cubed of theta up here. And I'm not seeing any sign of theta. So, you know what? I'm like, you know what? I probably don't want to bring in more signs. It looks like I'm trying to get rid of all those signs. So that's why I like this middle one here. There's not a sign of theta anywhere in there. So I'm going to rewrite cosine of 2 theta as 2 cosine squared of theta minus 1, which is getting multiplied to cosine of theta minus, and here I'm actually going to take the double angle formula for sine, which you might need to flip back to the first page if you printed the notes off, which is 2 sine of theta times cosine of theta. And we still have that being multiplied to sine of theta. So once again, like, okay, can I do anything here? Well, I can actually go ahead and distribute this cosine and distribute the sine to start to get cosine squared and even sine squared. And again, maybe that'll take us somewhere. So let's see what happens here. So here I need to distribute to both terms here. So this cosine of theta is going to the -1, and also to the 2 cosine squared of theta, which makes that 2 cosine cubed of theta minus cosine of theta. And then over here, since this is really, we have 2 times sine times sine again, I'm really just multiplying this one sign. So don't feel like you need to distribute it to every term. We only distribute to every term if there's plus or minus separating those terms. So this is really 2 sine squared of theta times cosine of theta. Like, okay, well, feel like we're getting somewhere, but there's still some work that needs to be done. And one thing that I mentioned before is we really don't want this sine squared of theta. So we need to figure out how can we rewrite sine squared of theta. Well, one thing that we learned in 5.1 is that one of the Pythagorean identities for trig functions is sine squared plus cosine squared of theta equals 1. Well, I can manipulate this and solve it for sine squared of theta so that I only have cosine, and that's by subtracting cosine squared of theta. So sine squared of theta is actually equal to 1 minus cosine squared of theta. So that's what I'm going to do next, is I'm going to replace this sine squared of theta, it's still 2 times that value, with 1 minus cosine squared of theta. And that still needs to get multiplied by cosine of theta. So we've got a bunch of things being multiplied here, and let's go ahead and multiply. So we can do this in a couple different orders. I'm going to go ahead and distribute the 2 into those terms first, and that's all I'm going to do this first step or this next step. So this is minus 2. So, actually, yeah, -2 times 1 is -2, and then -2 times negative cosine is a positive 2 cosine of 2 of theta. And all of that still needs to get multiplied to sine of theta or cosine of theta. So now I'm going to take this cosine of theta, I'm going to distribute it to the -2 and then also to this cosine squared of theta. So that first little section stays the same. It's still 2 cosine cubed of theta minus cosine of theta. This parenthesis probably should have been right there. And then minus 2 cosine of theta plus 2 cosine of cubed theta. Now the reason I did that is look what I did here. I created a bunch of like terms. I created a bunch of cosine cubes, which can be added with other cosine cubes. And I have some just cosine thetas that I can add together. Well, 2 cosine cubed plus 2 more cosine cubed is 4 cosine cubed of theta. And hey, that's what we wanted. And negative cosine of theta minus 2 more cosines of theta is -3 cosine of theta, getting us to the end of our identity. This is by far the hardest proof we've had to do yet, or the hardest trig identity we've had to do yet. And just remember, you might try something and it might not get you anywhere. So you've got to be willing to kind of retry. So when you're working on these on your own, find an entry point, see what rules you can use, what formulas you can use, think about where you're trying to end. So when you're working on this one on your own, you can notice you're trying to end with a bunch of sines. So any way we can get rid of those cosines is going to be kind of your best formulas to use. All right, so I do want you to try checkpoint 3. If you get stuck, go ahead and unpause and see what I have. But at the very least, I want you to try, and who knows, maybe you'll find a way that works. Maybe it might be different than mine. Maybe it might be exactly as mine. So go ahead and hit pause and work through and verify the identity of sine 3 of theta. You will start with the left-hand side here. Right, well, here are your steps, and once again, there's a lot going on here. So let's actually talk our way through this one. So similar to how I started off with cosine 3 of theta, I'm going to go ahead and split that 3 of theta up to 2 of theta plus 1 more theta, which allows me to go ahead and use that sum, sum formula for sine, which is equal to sine of 2 theta times cosine of theta plus cosine 2 theta sine of theta. Remember, that formula came from the 5.2 notes. So then I can use the double angle formula for sine 2 of theta, which gives us 2 sine of theta cosine theta. That's just what we got from the beginning of these notes. We still have that extra cosine of theta, so we have another cosine of theta being multiplied to what that double angle sine formula worked out to be. On the right-hand side, I apologize, I did have to cross something off. I didn't write it perfectly. To where I took cosine 2 of theta, and this time I'm like, okay, which direction do I want to go with? Well, I actually wanted to choose the 2 cosine squared of theta minus 1. So that was one of the formulas given up top there. So cosine 2 of theta is equal to 2 cosine squared theta minus 1 using the double angle formula times that sine of theta. So then I was able to do a couple different things. Over here on this left term, I can do cosine of theta times cosine of theta, which is cosine squared of theta. Everything else stayed the same. On the right-hand side, I went ahead and distributed this sine of theta. It can be 2 cosine squared of theta times sine of theta minus 1 times sine of theta, which is just sine of theta. Then, am I right? What next? Well, we actually have some like terms, and this is hard to see. If you look at this term, this is 2 sine of theta cosine squared of theta plus 2 more cosine squared of theta sine of theta. I know the order in which I'm writing the cosine squared and sine is different, but these are the same terms. This is like adding 2x plus 2 more x, giving us 4x. Well, 2 plus 2 is 4, and the term itself is sine of theta times cosine squared of theta. And then we still have that minus sine of theta at the very end. Well, I'm like, now I'm in business because I can take cosine squared of theta and using the Pythagorean identity, just the reverse now. So instead of solving for sine squared, cosine of squared is 1 minus sine squared of theta. So that's why that cosine squared of theta is getting replaced with 1 minus sine squared of theta. And we still have that minus sine of theta at the very end. And the last thing here is I can distribute this 4 sine of theta to both these terms, giving us 4 sine of theta minus 4 sine cubed of theta minus that last sine of theta. And combining like terms gets us to our final identity. And we are all done. Those are tricky. You need practice. I don't expect you to get it right away, but be willing to try. And if you don't get it, try a different route and see where it takes you. And keep in mind, you might have a different way of getting to the answer than me. All right, more formulas. These are the power reducing formulas. And like I've already said multiple times, you don't need to memorize these, just need to know how to use them. And we're going to use them here on the next page. But if you want to go ahead and write them down, go ahead and hit pause. That way you know where I'm taking these formulas from. Okay, so it says write an equivalent expression for cosine to the power of 4 of x that does not contain powers of trig functions greater than 1. I'm like, okay, what do I know about cosine 4 of x? Well, really what we're trying to do here is we want to use that power reducing formula, right? That's why I just gave it to you. that power reducing formula required us to have values of cosine squared of x. So cosine 4 of x is really equal to cosine 2 of x times cosine 2 of x. Well, anything times itself is that value squared. So let's think about this as cosine 2 of x squared, because now we can go ahead and replace this cosine 2 of x with that power reducing formula. And if you were to flip the page over, or maybe you wrote it down, you would see that cosine squared of x is equal to 1 plus cosine 2 of x over 2. And all that's being squared, because all I'm doing is taking cosine squared of x and using that formula that I showed us on the previous side. Well, now think about what it means to square it. Don't just distribute the square and call it 1 squared plus cosine squared of 2x over 4. We need to do this thing times itself, which means we need to FOIL. So actually, I'll just go ahead and write it out. So this is 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2. Well, the denominator is easy, right? 2 times 2 is just 4. Up top, though, we're going to have to FOIL. So I need to do 1 times 1 times cosine of 2x, so 1 plus cosine of 2x. Then cosine of 2x times 1, so another cosine of 2x. And then cosine of 2x times cosine of 2x, which is cosine squared of 2x. Well, the top can be simplified to be 1 plus 2 cosine of 2x plus cosine squared of 2x all over 4, which now, remember, if we're dividing all these three terms by 4, we can think about them as being divided separately. So 1 divided by 4 plus 2 cosine of 2x divided by 4. And it's really just the coefficient because this is 2 times that cosine of 2x. So that 4 over there, which is equal to 1/2, and then plus 1/4 of cosine squared of 2x. And then we're almost there. So the last thing we need to do is actually just use that power reducing formula one last time with cosine squared of x, and that'll get us really the final expression. And you might be like, it seemed like you made it more complicated, and you're right. I'm sure there are actually some true value in this besides just good algebra practice. So we're gonna leave the 1/4 the same. I am going to reduce 2 over 4 to be 1/2 cosine of 2x, and then bring it in the power reducing formula for cosine squared of x. Notice the one difference here is we do have 2x as opposed to just x like we had before. So when I bring that formula in, it's 1/4 and then 1 plus cosine of 2 times that value of what used to be x, but since it's 2x, it's actually going to be 4x here over 2. Right, and the last thing that we need to do, well, 2 more things, is let's go ahead and multiply this fraction here. So that works out to be 1/4, 1/2 cosine 2 of x, so nothing changes there. And this is actually 1/8. So really what I'm doing 2 things. I'm distributing the 1/4. So this is 1/4 plus 1/4 cosine 4 of x, all of which is being divided by 2, making that denominator 8. So then plus another 1/8 cosine of 4x. All right, also could have just distributed the 4 here to make that denominator 8 and dividing each of them separately. So a couple of ways you can think about that. All right, and the last thing is to just combine any like terms. And those like terms are just 1/4 and 1/8. If you get a common denominator, you're going to find that those combine to give us 3/8. And everything else is going to stay the same. Cosine of 2x plus 1/8 of cosine 4x. So a lot of work to create something that looks more complicated than what we originally had. But like I said, good practice, and I'm sure there's some value that we'll see down the road. Okay, well, it is your turn to try. You're going to work with sine to the power of 4 of x, and it's going to work out almost identical. Just this time you're using the power reducing formula for sine. So go ahead and hit pause, work through this. I'll have your work, the work shown after you unpause. All right, well, here's the work shown, and works out very similarly to what I had to do as I went through example 4. And really our end equation is almost identical, just a couple sign differences. So I'm not going to explain these steps here. If there is something that you're not quite sure what I'm doing, because I didn't show quite as much work as I had above, then feel free to pop into office hours or shoot me an email and I can explain a little more in depth. But yeah, there's your work for that one. I'll also post these notes, so if you want to look a little more closely without the video being paused, they'll be on Schoology. You can check your work there. All right, more formulas. We're almost all done with all these formulas. And the one thing I'm going to say about these is, once again, jot these down in your notes if you're keeping track of everything. And the one thing that you'll notice here is we have plus or minus. And they make a really important note about this below, saying that the plus or minus symbol in each formula does not mean that there are two possible values for each function, like we typically see with square roots. Instead, the plus minus indicates that you must determine the sign of the trig function. And that is based on which quadrant the half angle lies. All right, so we're going to either use positive or negative depending on where the angle that we're dealing with, which quadrant it falls under. So we can use those half angles to find values of different angle measures for our trig functions. So we want to find, what is cosine of 112.5? Well, without the use of a calculator, we need to use kind of things that we can do with using the unit circle. So I'm like, okay, I know I want to use that half angle formula. So I'm like, what angle divided by 2 gives me 112.5? That'd be 225, right? So instead of finding cosine of 112.5, we're really finding cosine of 225 divided by 2, right? Those are equivalent, which now, if you flip back to what that cosine, the half angle looks like, it's going to be equal to the square root. We'll come back and determine the sine in a second, of 1 plus cosine of the angle, and think in general it's alpha, so 225 degrees, all that's over 2. Well, let's figure out if we want plus or minus here, and this depends on where does 112.5 degrees fall. Well, we got 0 degrees, 90 degrees, 180 degrees, so it's somewhere over here. When we're over here, we know that x is negative, y is positive. Since we're dealing with cosine, cosine is the x coordinate. So cosine of any value in the second quadrant is going to be negative. So we're going to use the negative root here. So we need to figure out, what is cosine of 225? Well, once again, this is where we want to know how to use our unit circle. If you have the unit circle, it's really quick, but sometimes we don't have that luxury and we might need to figure out on our own. So I'm going to draw another diagram over here, this one resembling our unit circle. So 0, 90, 180, 270. I knew 225 falls in between 180 and 270. What I want to figure out is exactly how far does it fall. Well, 225 is 45 degrees more than 180 and 45 degrees less than 270. So we're using, like what we would see in the first quadrant, this 45 degree angle, which is root 2 over 2, root 2 over 2. But now that we're in quadrant 3, it's the same values, just the sign is opposite for both x and y. So negative root 2 over 2, comma negative root 2 over 2. So that's how we can use that unit circle to come up with values, and why, if you know the first quadrant, you can find values of other quadrants pretty quickly. So now we know we still have negative square root of 1 plus the value of the square root, or of cosine of root 225, which again is the x coordinate. So that's negative root 2 over 2, all that over 2. The next thing, and this can be a little tricky, is we need to simplify this fraction here. So what I'm going to do is I'm going to do some side math, where I'm going to take what we're taking the square root of. I'm going to work on simplifying that. So this is 1 plus negative root 2 over 2. And let's actually go ahead and say, since we have a fraction divided by a value, let's copy the top, change division and multiplication, and flip the bottom. So instead of this being multiplied by 2 over 1, we're going to multiply it by 1 over 2, the reciprocal. I'm going to distribute this 1/2 because it's this whole top divided by that bottom, giving us 1/2 plus, this would be, well, 1 times -√2 is still -√2. 2 times 2 is 4. And getting a common denominator, this would be 2/4 plus √2, -√2 over 4, which, remember, if we're dividing by the same denominator, we can take the numerators and divide it by just one denominator. So this is really like 2 plus -√2 or 2 minus √2 over 4. And so this is actually equal to -2 minus √2 over 4. Remember yesterday I showed you in the calculator how you can check to make sure that those values are correct. So I could go to my calculator and figure out what is cosine of 112.5 degrees. Is that equal to the same value as the negative square root of 2 minus √2 over 4? And you're going to find that they are in fact the exact same. Now, I lied. We have one more thing to do. And this is something Math Excel will want you to catch. So I'm glad I'm bringing this up. So not done yet. If we're dealing with square roots, know that you can take the square root of the top separate from the bottom. So I can do the square root of 2 minus √2, which we can't do anything with. But on bottom, √4, we have a value for that, right? √4 is actually 2. So Math Excel is going to want this reduced down to have that denominator of 2. So really tricky, kind of sneaky to get that divided by 2 in there. But now we're only taking the square roots of the numerator, which is, in general with algebra, we never want to take square roots of the denominator, only the numerator. All right, well, once again, I'm going to have you hit pause and work through the next checkpoint. All right, here's the work. Works out almost identical. It's nice that they give us the value of cosine of 210. Know that we actually are trying to find the value of cosine of 105. So that's why it's 210 divided by 2. And on that, almost identical. So once again, if you have questions and not sure how I'm coming up with things, feel free to shoot me an email or pop in office hours and I can explain it. All right, almost done. Just a couple more things. So the last one is just, once again, verifying identities. There's lots and lots of practice with this, as is good algebra practice. So know that most of the time we've been working with the left-hand side, but in general, we kind of want to work with the more complicated side, which in this case is the right-hand side. So I'm trying to go from this right-hand side to get it equal to tangent. So I'm just going to write down that left-hand side, which is 1 minus cosine of 2 theta. And as I'm writing, I'm like, okay, I have a double angle formula for cosine divided by sine squared, or 2 of theta. And I know I have a formula for the double angle of sine. So we need to figure out which ones we want to use. Well, I'm trying to get to tangent, and I know that tangent, and I'm already seeing I have a bunch of cosines and sines. Tangent is equal to sine over cosine. So I'm like, okay, I'm probably going to want to keep all those sines and cosines around and eventually kind of get to where I can divide things out so I end with sine over cosine. So I'm thinking about, where do I eventually want to get to? Well, the first thing that we're going to go ahead and do is rewrite or use the cosine 2 of theta and rewrite it with one of those double angle formulas. And remember, there's multiple in there. I'm going to actually use the one that brings in sine. So this is 1 minus, and then cosine 2 of theta can be rewritten as 1 minus 2 sine squared of theta. Now, the reason I'm choosing to do that is because I'll eventually get it to cancel out with some sines on bottom and allowing just to have a sine up top. Now, in my denominator, in order to get to tangent, which has, again, a sine over cosine, I need some cosines in my denominator. So that double angle formula for sine squared of theta does exactly that, right? It's equal to 2 sine of theta times cosine of theta. Well, now we can do some things. Up top, I have 1 minus 1, right? This 1 is really being distributed. Well, 1 minus 1, that's 0. Those cancel. Negative 1 times this minus 2 sine squared of theta is actually positive 2 sine squared of theta over our denominator of 2 sine of theta cosine of theta. And we're just about there because these 2's divide out because they equal 1. one sine of theta cancels out with one other sine of theta. And so I just have sine of theta divided by cosine of theta, which is exactly what I was trying to get to, which is equal to tangent of theta. So a little bit quicker identity, but again, the trick is which of those double angle formulas for cosine do we want to use? Well, I'm going to let you try to apply that thinking process as you work to verify the following identity to once again get it to equal tangent. So go ahead and hit pause. You might need to look back at some of those formulas to figure out where to get to. I'll have the answer for you shortly. All right. Well, here is the work for the identity. Works out almost identical. There's only one choice for the double angle of sine. When you're figuring out which one you want to use for cosine 2 of theta, we actually want to bring in more cosine squareds, or excuse me, cosines, so that way we can get that sine over cosine value to eventually get tangent. So work is almost the same. The trick is finding which of those double angle formulas for cosine do we want to use. All right. Well, one last thing, and again, we're going to use just some identities with these. These are the half angle formulas for tangent. I gave them to you for sine and cosine, but here's the last one for tangent. And we're just simply going to go ahead and verify identities with these. So we're trying to get to this half angle formula for tangent. So we're going to start with the right-hand side again. So cosecant of alpha minus cotangent of alpha. How can we get that to be tangent of alpha over 2? Well, let's write, what do we know about cosecant and cotangent? Well, we know that we can write them as sine and cosines, where cosecant is 1 over sine of alpha. Cotangent is actually equal to cosine of alpha over sine of alpha. Well, as you look at that, they have a common denominator, so this is really 1 minus cosine of alpha over sine of alpha. I'm like, I don't really know what to do here, but if I look up here, aren't those the same? 1 minus cosine of theta over sine of, or alpha, is equal to tangent of alpha over 2, which is exactly what we're trying to end with. And so we can just simply say that 1 minus cosine of alpha over sine of alpha is equal to tangent of alpha over 2. So that's a quick identity. I'm going to have you try with the last checkpoint. So go ahead and hit pause, work through that. That's the last thing that we've got. Right, actually a little more work here. And again, start with what do you know? So when you're working with secant, you know that that's 1 over cosine, and we have that twice. Cosecant is 1 over sine. We have that twice. So all I'm doing is just rewriting those. Then I'm going to work to simplify, where I can multiply these two fractions, and it just gives me 1 over cosine of alpha times sine of alpha. Then we have this additional adding 1 over sine of alpha. So if I want to, the goal is to get the denominator to be 1 fraction. So in order to add these two, I need a common denominator. So I'm multiplying this by cosine of alpha over cosine of alpha, giving us cosine of alpha over that common denominator, which I can then add these two fractions. So 1 plus cosine of alpha over that common denominator. So I'm able to take the top and copy, change division and multiplication, and flip the bottom. And that's what you're seeing down here, where we eventually get a cosine of alpha to cancel out, leaving just sine of alpha up top over 1 plus cosine of alpha. And if we look back, that is equal to the other half angle of tangent, which is sine of alpha over 1 plus cosine of alpha, giving us the identity. All right, well, lots of practice here, and not really we need our own practice. These are tricky. Now, the last thing that I'm just going to show you is a summary for all the formulas that we've talked about the past couple lessons. If you're taking your own notes, I would absolutely write these down. If you print them off, then keep these handy, as you're going to need to use them at various times as you work through the Math Excel assignments. All right, well, thanks for watching. Have a great day. If you have any questions, please don't hesitate to reach out.